Hello, my dear students. Welcome to Sankalp Learning Classes. Today we are discussing the important question answer from the chapter that is the human eye and the colorful world. Okay. So, yes. So, I hope all are ready to listen the class. Let us start with the chapter with multiple choice questions. Okay. So first we are discussing the multiple choice questions. After that we are discussing the 1 mark and 2 mark questions as well as long answer questions. So like that. So we are discussing the important questions from this chapter. Let us start with the first question. The human eye and the colorful world. Observe the given figure. Identify the eye defect indicated in this figure. Okay. Option A, presbyopia. Option B, hypermetropia. Option C, myopia. Option D, cataract. Okay. So just see the diagram. So here you can see the image which is formed here, right? Commonly image form should form on the retina, but you can see the image formation here. So if you see the diagram, you can easily say that this is the type of the eye defect, that is myopia, right? Option C, myopia. In case of hypermetropia, images will form here in this place, right? So just in front, behind the retina. So this is in front of retina. Okay. So the correct answer is option C, myopia. Okay. Please note down the question. Next question. Observe the following table here. In the table here, the material medium PQRS are the different medium, and this is the refractive index is given in the another column. So you can see the 1.52 refractive index and Q that is having the 1.44 refractive index and R that is having the 2.42 refractive index and S that is having the 1.33 refractive index. So here in which material medium the speed of light is very high? Option A, Q. Option B, P. Option C, yes. Option D, R. Okay. So here, so if you see the refractive index, but this topic is deleted from your syllabus here. Refractive index, when the refractive index of the medium increases, the speed of the light that is decreases, right? So here, so which one is the refractive index is that is very less, that is having the light speed high. Okay, so in the where the refractive index is very less, there the light speed is very high. So you can say here 1.44, here 1.3352. So this one S, which is having the 1.33. So the correct answer is option C, S. Okay. Next question. The sky as seen from the surface of the moon appears dark because. Why sky looks dark when you observe it from the space? Option A, only a little of the blue and violet colors scatter. Option B, all the colors are absorbed by the atmosphere present in the moon. Option C, all the colors are scattered. Option D, atmospheric particles needed to scatter the light are not present. So here, only a little of the blue and violet colors are scattered. No, that is not correct. All the colors are scattered by the atmosphere present in the moon. No, that is not correct. All the colors are scattered. No. Here, atmospheric particles needed to scatter the light are not present. Yes, this is the correct answer. So, atmospheric particles are required for the scattering of the light. So, here, the sky as seen from the surface of the moon appears dark. So the correct answer is option D. Please note down this. Next question. The human eye can focus on the objects at different distances by adjusting the focal length of the eye lens. This is due to presbyopia, nearsightedness, accommodation, farsightedness. Here, the correct answer is, so you know that human eye that can focus on the objects at a different distance by adjusting the focal length of the lens. Here, which is the correct answer? Please note down the answer. Sorry. Here, the correct answer is accommodation. So, human eye that can focus the object at different distances by adjusting the focal length of the eye lens. This is due to the accommodation. Option C is the correct answer. Next question. The human eye forms the image of an object at its cornea, iris, pupil, retina. Here, the eye forms the image of an object at its, so which of the place? The image will form on the retina. The correct answer is option D, that is retina. Please note down the answer. Next question. The least distance of distinct vision for a young adult with normal vision is about option A 25 meter, option B 2.5 centimeter, option C 25 centimeter, option D 2.5 meter. Here, the least distance of distinct vision for a young adult with normal vision is it 25 meter? No, that is not correct. 2.5 centimeter, that is also not correct. The correct answer is 25 centimeter. The correct answer is 25 centimeter. Please note down this answer. Next question. The change in focal length of an eye lens is caused by the action of the option A pupil, retina, option C ciliary muscles, option D iris. The change in the focal length of an eye lens, so how it is caused? By the action of which one? Is it by the action of pupil? No. Is it by the action of retina? No. The correct answer is ciliary muscles. The correct option is option C, due to the action of the ciliary muscles. Next question. A type of lens used to correct the nearsightedness. Option A, convex lens. Option B, concave lens. Option C, bifocal lens. Option D, concave convex lens. Here, a type of lens used to correct the nearsightedness where the object is formed, that is just in front of the retina. So here, which type of the lenses are used? That is concave lens. So you can see the lenses like this. That is the concave lens. Next question. The color of the sky as seen from above the moon. Option A blue, option B purple, option C red, option D black. So from if you observe the sky from the moon, it looks in blue color, no purple, red, no other colors. It looks in a black color. What is the reason? Because there is no atmosphere is present and the moon for the scattering of the light. So if the scattering of the light is absent, then there is no blue or other color dispersion takes place. So option D, that is the black color is seen when you observe the sky from the moon. Option D is the correct answer. Next question. The crystalline lens of the people at old age becomes milky and cloudy. This condition is called cataract, myopia, presbyopia, hypermetropia. Here, the myopia and presbyopia, hypermetropia, these all are not related to the age. But here, cataract, that is related to the old age groups. The crystalline lens of the people at the old age, so that will become milky and cloudy. So that is because of the option A, that is called as cataract. Okay, option A is the correct answer. Next question. The color that least scattered by fog and smoke is option A orange, option B blue, option C red, option D violet. Which color scatter by fog and smoke, that is least scattered color by fog and smoke, that is option C red color. So that is the correct answer. Option C red color. Please note down this question. Okay. So next question. Identify the wrong statement among the following statements regarding refraction and dispersion of light. Option A, stars twinkle. Option B, sky appears blue to an astronaut flying at the very high altitudes. The sun is visible to us about 2 minutes before the actual sunrise. Planets do not twinkle. Here you have to identify the wrong statement given here. Okay. So which one is the wrong statement that you have to identify? Stars twinkle. Yes, that is the correct statement. Sky appears blue to an astronaut flying at the very high altitudes. Sky does not look blue color for an astronaut flying at the high altitudes because there is no atmospheric particles are present to scatter the light. So option B is the wrong statement. Then see the option C. The sun is visible to us about 2 minutes before actual sunrise. That is also correct statement. Planets do not twinkle. Yes, that is also option D is also correct statement. So which one is the wrong statement here then? Option B. The sky appears blue to an astronaut flying at very high altitude. Option B is the correct answer. Okay, let us move to the next question. Let's see the next question. How does lens of human eye accommodate to see the nearby objects and distant objects? Explain. Explain the formation of rainbow in the nature. Yes. Please write down the question. After that, we are going to discuss the answer for this question. This is the 4-mark question. So, A question that is for 2 marks, and this one that is also for the 2 mark. How does the human eye accommodate to see the nearby objects and the distant objects? Explain. Then explain the formation of rainbow in the nature. Please note down this question. Yes, the eye lens is composed of fibrous jelly-like material. Its curvature can be modified to some extent by ciliary muscles. The change in the curvature of the eye lens can thus change its focal length also. When the muscles are relaxed, the lens becomes thin. Thus, its focal length increases. This enables us to see the distant objects, how it is focusing the distant objects. Then when we are looking at the objects closer to the eye, the ciliary muscles contract. This increases the curvature of the eye lens. Then the eye lens then becomes thicker, and consequently the focal length of eye lens decreases. This enables us to see the nearby objects clearly. So like this, the eye that accommodate to the so that focus the nearby objects and the distant objects. Next one, B. Explain the formation of rainbow in the nature. So that is also very important question. Many times this question asked in different question paper. Okay, board exam question paper also. Here explain the formation of rainbow in the nature. A rainbow is a natural spectrum appearing in the sky after a rain shower. It is because it is caused by the dispersion of sunlight by tiny water droplets. So small tiny water droplets. So the dispersion of light. So each tiny water droplets, they act as a uh, so they scatter the light. A rainbow always formed in the direction opposite to the that of the sun. So each water droplet that act as a small prism. Yes, so it act as a small prism where they refract the dispersed light and the incident sunlight, then reflect internally and finally refract it again when it comes out of the raindrop. So when the light falls on the raindrop, they refract and disperse the incident sunlight. So there is a internal reflection takes place, then finally so it refract it again. Okay, so Due to the dispersion of light and internal reflection, different colors reach the observer's eye. So that is how the rainbow will form in our nature. Very important question. Explain the formation of rainbow in the nature. Okay. Okay. Next question. Yes, it is also same question, repeated question. How does rainbow form in nature? Explain. Mention the color of light that bends the most and bends the least. Okay. Mention the color which bends the most and bends the least. Then second question. So read the B question. This is also 4 mark question. For question A, 2 mark, and question B, that is also for the 2 mark. Okay. How does the eye lens accommodate to see the distant objects and nearby objects? Explain. Please note down this question. Yes, you have already noted down this question. Please note down the second one, that is mention the colors. Mention the colors of light that bends the most and that bends the least. Next. Yes, already we have solved this. How does rainbow form question in the nature? That question. And how does the eye lens accommodate to see the distant objects nearby and the nearby objects? Explain. So that is also we have solved in the first question, right? So both are same question, but very important because repeated question. So I kept this in 2 slide. Then here, which light? So there is a second question. Mention the color of the light that bends the most and here that bends the least. Here red color that bends the least and violet bends the most in rainbow. Please note down this answer. Red light bends the least and violet bends the most. Okay. The next slide. What is refraction of light? Yes, this question is not that for your syllabus, refraction of light, but very important for your knowledge. Refraction is the bending of light as it passes from one transparent substance into another. Please note down the question. What is refraction of light? So commonly, you know the word reflection, refraction. So what is the definition of the refraction of light? That is, refraction is the bending of light as it passes from one transparent substance into another. So that is the refraction of light. Next question. A student sitting in the last bench has difficulty in reading the blackboard writing. Which is the defect of vision the student has? How can it be corrected? Please read the question. Yes, dear students, I know you have covered these all topics in your school, but it is the time for the revision. So please see the question. If you know the answer for that question, please try to write the answer for that question. That will be so helpful for you for practice, right? Then if you don't know the answer, just I will keep the slide for the answer also, so you can note down that answer. Okay, so like that, please take the use of this class. A student sitting in the last bench. Yes, so the student is, just to see, this is the blackboard. Just imagine this is the blackboard. Okay, and the student is sitting here, so just far away from this blackboard, reading the blackboard. He is not able to read what is written on this blackboard, what is there on blackboard. Okay, What type of the defect, vision defect the student has, how can it be corrected? So he's not able to see the far object, but he is able to see the nearby object. He is able to read the near. So that is the assumption what I'm doing here. Then what type of the defect it is? Anybody? So that is the myopia or near sightedness. So myopia. So how it can be corrected? It can be corrected by using the concave lens. It can be corrected by using the concave lens. Okay. So that is the disease is, that is nearsightedness. Then which type of lens we can use here? That is the concave lens. Next question. In the given figure AB, the incident ray here, AB is the incident ray which incident on the which moves from medium 2 to the medium 1. So this topic is also not there for your syllabus. BC is the refracted ray. So this is the refracted ray, and MN is the normal at the point of incident. So this is the normal at that point of incident. Which medium is more denser? Why? Here medium 1 is mentioned, medium 2 is mentioned, right? Which medium is more denser? So when the um, incident ray, so this is the normal at the so if it bends towards this MN, so this ray, then the medium is, so that is denser than the medium 2. So this medium is less denser compared to the medium 1. So if the incident ray, when it enter to the medium 1, it moves away from this ray, this MN ray, then it is the medium one that is having the more denser. So that you can say, sorry, less denser. So that is the reason here what we can say, which medium is more denser? Why? Here medium 1 is denser, medium 1 is denser medium. Why? Because when the light moves from medium 2 to the medium 1, so light, which medium is more denser? Less denser medium to the more denser medium, the light bends towards this MN ray, then so it is a denser medium. Medium 1 is the denser medium. Okay. Next question. Draw the diagram to show the recombination of spectrum of white light and label the following parts. The ray of light that bends the most and the ray of light that bends the least. Please note down this question. Draw the diagram to show the recombination of spectrum of white light. So you know that spectrum of white light that contains the 7 different colors. So here, so this is the white light. So where the dispersion work occurs, and so 7 different colors are there. So when it moves in the second prism, so again it converted into a white light. Next question. Observe the given figure. Name the eye defect indicated in the figure and also mention the lens used to correct this defect. Yes. Please note down the question. Here, name the eye defect indicated in the figure. So you just observe the figure and say the eye defect. So that is the myopia, right? So in the question number 1, we have solved this. So this type of the So here you can observe the image formation in here, not on the retina, right? So if the image is formed here means, so this is nothing but the nearsightedness, right? So also called as myopia. And mention the lens used to correct this defect. Which type of lens is used here to correct the myopia? Yes, anybody? Those who know the answer, just comment in the... Okay. So that is the concave lens. Next question. What is Tyndall effect? Please note down this question. What is Tyndall effect? Here. What is Tyndall effect? The phenomenon of scattering of light by the colloidal particles gives rise to the Tyndall effect. So that is the definition of the Tyndall effect. Next question. What is dispersion of light? Mention the color that bends the least and color that bends the most when the light undergo the dispersion through the prism. Please note down this question. What is dispersion of light and which color bends the least and which color bends the most when it undergoes the dispersion through the prism? Yes. What is the answer? The splitting of white light into its components colors is called dispersion of light. Violet bends the most and red bends the least in the spectrum. Again, I will show the question once again. Yes, answer for this question. Please make a note on this question. Next one. Mention any four phenomena that can be observed due to the atmospheric refraction of light on Earth. So, what are the four phenomena? Just you have to mention, that is for the 2 mark questions. Here, twinkling of stars, early sunrise and delayed sunset, apparent change in the position of the sun or stars, blue sky. So these are the some phenomenon that is because that is observed due to the atmospheric refraction of the light. Okay. Once again, note down the question. Twinkling of stars, early sunrise and delayed sunset, apparent change in the position of sun or stars, and blue sky. What is meant by power accommodation of the eye? What is meant by power accommodation of the eye? Please note down this question. The ability of the eye to focus the distant objects as well as the nearby objects on the retina by changing the focal length or converging power of its lens is called as accommodation. The normal eye has the power of accommodation which enables the object close as the 25 centimeter and far as infinity to be focused on its retina. Okay, so next question. A person with myopia eye cannot see objects beyond 1.2 meter distinctly. What should be the type of corrective lens used to restore the proper vision? Here, so he's not able to see the objects beyond 1.2 meter. So what type of the lens should be used for the correction here? Here, the myopia eye person that is be cured by using the concave lens. So this type of lens, that is the concave lenses are used for this. Next question. Yes, so this is the answer. A person with myopic eye cannot see the objects beyond 1.2 meter distinctly because in a myopic eye, the image of a distant object is formed in front of the retina. This defect can be corrected by using the concave lens. Next question. What is the far point and the near point of the human eye with normal vision? What is the far point and what is the near point? So that you have to mention for the 2 mark question. So this is the 2 mark question. Yes, here. Far point of the human eye with normal vision is near than the infinity and near point is 25 centimeter. That is very important. The near point is 25 centimeter and the far point is, so that is near than the infinity. Next question. Why is a normal eye not able to see clearly the objects placed closer than the 25 centimeter? So if the object is closer than the 25 centimeter, the normal eye not able to see that. So what is the reason? Because the maximum accommodation of normal eye is reached when the object is at the distance of 25 centimeter from the eye, right? The focal length of eye lens cannot be decreased below this minimum limit. So, thus an object placed closer than 25 centimeter cannot be seen clear by a normal eye. So, that is the reason. Please note down this question. Next question. What happens to the image distance in the eye when the increases the distance of an object from the eye? So what happens to the image. The distance eye lens and the retina is the image distance inside the eye. The image distance is fixed. It cannot be changed at all because when we increase the distance of an object from eye, there is no change in the image distance inside the eye. So, next question. Why do stars twinkle? Why do stars twinkle? The twinkling of star is due to the atmospheric refraction of the starlight. The atmospheric refraction occurs in a medium gradually changing the refractive index. Okay, so that is the twinkling of stars, that is because of the atmospheric refraction. Since the atmosphere bends starlight towards the normal, the apparent position of the star is slightly different from its actual position. This apparent position of the star is not stationary but keeps on changing slightly. So that is not fixed, that keeps on changing. As a physical condition of the earth atmosphere are not stationary, since the stars are very distant, they approximate point sized sources of light. As the path of rays of lighting become coming from the star goes on varying slightly, the apparent position of the star fluctuates and amount of starlight entering the eye flickers some other time. So fainter, which is the twinkling effect. So that is the reason why do stars twinkle. So actual phenomena, what happens there? What is the reason behind the twinkling of the star? Next question. Explain why the planets do not twinkle. Explain why the planets do not twinkle. The planets are much closer to the Earth and are thus seen as extended sources. If we consider a plant as a collection of large number of point-sized sources of light, the total variation in the amount of light entering our eye from all the individual point-sized sources will average out to zero, thereby nullifying the twinkling effect. So that is why planets do not twinkle. Why does the sky appear dark instead of blue to an astronaut? So we know the reason for this question. When the sunlight passes through the atmosphere, the fine particles scatter the blue color, where the shorter wavelength more strongly than the red. The scattered blue light that enters our eyes, and so it looks blue color. If the earth had no atmosphere, there would not have been any scattering of light because so in the space there is no atmosphere for the scattering of the light, so sky appeared dark instead of blue to an astronaut. So like this you can write the answer for this question. So this is the detailed explanation for this question. Next question. What is presbyopia? Explain how to correct this defect. What is presbyopia? Explain how to correct this defect. The power of accommodation of the eye usually decreases with aging. For most people, the near point gradually recedes away. They find it difficult to nearby objects comfortably and distinctly without corrective eyeglasses. It rises due to the gradual weakening of the ciliary muscles and diminishing the flexibility of the eye lens. So sometimes a person may suffer from the myopia and hypermetropia. So both lenses, that is bifocal lenses, should be used to correct this defect. So this is due to the aging. Next question. Explain the Tyndall effect. So what is Tyndall effect? That is for 1 marks. Explain the Tyndall effect. It can be asked as a 3-mark question. Please note down the answer. What is Tyndall effect and how it occurs? The Earth's atmosphere, so that is the heterogeneous mixture of minute particles. You know that. So when a beam of light strikes on the fine particles, the path of the beam becomes visible. The light reaches us after being reflected diffusely by these particles. The phenomenon of scattering of light by the colloidal particles gives rise to the Tyndall effect. Why does sun appear reddish early in the morning? So this is the general question. Why does the sun appear reddish early in the morning? Yeah. Light from the sun near the horizon passes through the thicker layers of the air and larger distance in the earth atmosphere before reaching our eyes. However, light from the sun overhead would travel relatively shorter distance. At noon, the sun appears white as only a little the blue and violet colors scatter. So that is the reason. Near the horizon, most of the blue light and the shorter wavelengths are scattered away from the particles. So therefore, the light that reaches our eye is longer wavelengths. This gives rise to the reddish appearance of the sun. Draw a neat diagram showing the near point of hypermetropic eye, hypermetropic eye, then correction of the hypermetropic eye. So very important, this question asked in the last year question paper also. Please note down this question. Here. Yes, so these are the three diagrams. So which indicate the near point of hypermetrophic eye, then hypermetrophic eye, then the correction of the hypermetrophic eye. Please practice these three diagrams. That is very important. Okay. Next one. So this is also same question. Draw the ray diagrams that show the near point of hypermetrophic eye, and the second one hypermetrophic eye, and the third one correction for hypermetropic eye. So these all three are same here. So this is the answer. Next question. What is spectrum of white light? Name the two phenomena that occur atmosphere due to the refraction of light. Here we know the what is spectrum of white light. Answer for that question. Name the any two phenomena that occur in the atmosphere due to the refraction of light, that is twinkling of the stars and the sunrise which appears 2 minutes before actual sunrise. These all are the some phenomenon. So that is due to the refraction. Please note down this question. Next question. What is cataract eye? What are the near point and the far point of the human eye with a normal vision? Here, a cataract eye is the cloudy area that forms in the lens of the eye which cause the vision loss. Okay, so that is common part of the aging and can affect the one or both the eyes. So that is the definition you have to write. What are the near point? Near point is the 25 centimeter and far point, that is the infinity, the human eye with the normal vision. Okay. So dear students, we have discussed this much questions related to this chapter. I hope these questions are very useful for your board exam. Keep practicing. Thank you. I will continue in the next class.